Assalamu alaikum, dear students. How are you? I think all of you are well in grace of Almighty Allah. I am also fine. I am Hiron, Associate Professor and Head of the Department, Statistics Department, Eden Mohila College, Dhaka. Welcome to all of you on behalf of Eden Mohila College online class. Today I shall discuss with you central tendency, first year non-major course non statNM 101, Introduction to Statistics. This is half unit course, that is 2 credit, 50 marks. 15 is in course and 35 is exam. Okay, I shall start. Central tendency. What is central tendency? At first, definition of central tendency: the measure which usually reflects the complete data set and falls in the center of the array is known as measures of central tendency, since it tends to lie in the center. The measure which usually reflects the complete data set and falls in the center of the array is known as measures of central tendency, since it tends to lie in the center. Various measures of central tendency are arithmetic mean, in brief AM, to geometric mean, that is GM, harmonic mean, that is HM, number 4 median, number 5 mode. What is arithmetic mean? Arithmetic mean is an average or central value of a set of observations obtained by summing those observations and then dividing this sum by the number of such observations. The arithmetic mean is an average or central value of a set of observations obtained by summing those observations and then dividing this sum by the number of such observations. Let X has n observations, x1, x2 up to xn. Then arithmetic mean is m or x bar equal to x1 plus x2 plus xn divided by n, summation xi by n. For group data, in case of frequency distribution, for group data, arithmetic mean is x bar equal to summation fi xi by capital N, where fi is the frequency. It has merits and demerits. merits. It is rigidly defined, it is easy to understand, it is easy to calculate, it is suitable for further mathematical treatment. It is rigidly defined, it is easy to calculate, easy to understand, it is suitable for further mathematical treatment. Disadvantage: it is affected by extreme value, it cannot be found out graphically, it may not be representative in the data set. Disadvantage: it is affected by extreme value, it is not found by graphically, that is, we cannot find arithmetic mean from the graph. It may not be representative in the data set. This is arithmetic mean. Next, geometric mean. Geometric mean. The geometric mean G of n non-zero positive values x1, x2, xn is defined as the nth positive root of the product of the values. The geometric mean G of n non-zero positive values x1, x2, xn is defined as the nth positive root of the product of the values. That is, symbolically we can write G equal to x1, x2 up to xn 1 by n. This is ungrouped data. For group data we can write, for group data we can write G equal to x1 f1, x2 f2 up to fn, xn 1 by n. For group data we can write. It also has some merits and demerits, that is advantage and disadvantage. Merits or advantage. Number 1, it is less affected by extreme values. It is definite formulate to calculate. It is suitable for further mathematical treatment. It is less affected by extreme values. It is definite formulate to calculate. It is suitable for further mathematical treatment. Demerits. It is not easy to calculate, it is not easy to understand, it is not calculate if any of the observation is 0. That is, any observation of the series is 0, then we cannot calculate a geometric mean. This is the main disadvantage of geometric mean. It is not easy to understand, it is not easy to calculate. We cannot calculate geometric mean if any observation is 0. Next, harmonic mean. Harmonic mean. Harmonic mean is defined as the reciprocal of the arithmetic mean of the reciprocals of the independent values. Harmonic mean is defined as the reciprocal of the arithmetic mean of the reciprocals of the independent values. if we consider n values, that is x1, x2, xn, then harmonic mean is hm equal to n by 1 by x1, 1 by x2 up to 1 by xn, that is n summation 1 by xi, I equal to 1 থেকে 1 to n. This is ungroup data. For group data we can write hm equal to n summation fi by xi equal to 1 to n. This is also has merits and demerits. Merits: it is calculated using all observations. It is not affected by extreme values. It is suitable for further mathematical treatment. Merits: it is calculated using all observations. That is, if we consider 5 observations, then we can use 5 values to calculate harmonic mean. That is, harmony, it is calculated using all observations. It is not affected by extreme values. It is suitable for further mathematical treatment. Demerits: it is not easy to calculate. It is not easy to understand. It is not calculated if any observation is 0. It is not easy to calculate. It is not easy to understand. It is not calculated if any observation is 0. That is, if any observation of the series is 0, that is 2, 0, 5, 8, 10. In this case, we cannot use harmonic mean because any of in the series one observation is 0. Median: median is that value of the series which divide the array of the series into 2 equal parts, such that half of the observations are below it and another half of observations are above it. Median is that value of the series which divides the array of the series into 2 equal parts, such that half of the observations are below it and half of the observations are above it. For ungrouped data, median is n plus 1 observations if n is odd, n by 2 term plus n by 2 plus 1 term by 2 if n is even. This is ungrouped data. Ungrouped data. For group data, m equal to L plus n by 2 minus Cf Fm into C, where L lower limit of the median plus C width of the median plus F frequency of the median plus Cf of the class preceding median plus n total observations. L is the lower limit of the median plus C class interval of the median class, FM frequency of the median class, CF cumulative frequency of the class preceding the median class, N total frequency. It has also merits and demerits. Merits. It is easy to calculate, easy to understand. It can be found out from the graph. It is rigidly defined. It is easy to calculate, easy to understand. It is found out from graph. It is rigidly defined. Demerits. It is not based on all the observations. It is not suitable for further mathematical treatment. It is not based on all observations. It is not suitable for further mathematical treatment. Mode. Mode. Mode is that value of the variables which occurs most frequently in the series of observations of the variable. Mode is that value of the variables which occurs most frequently in the series of observations of the variables. For example, if we consider the series 2, 3, 5, 8, 11, 8, 3, 13, 20, 11, 8. Here we can see that 8 occurs 3 times, 11 occurs 2 times, 3 occurs 2 times. So mode 8. Since it is most frequently occurs in the series, so mode is 8. There mode 8. For group data, we can write L plus delta 1, delta 2 into C, or L plus F1 minus F0, 2F1 minus F0 minus 2 into C. L is the lower limit of the model class, C class interval of the model class, F1 frequency of the model class, F0 frequency of the class preceding in the model class, F2 frequency of the class following in the model class. Merits. It is easy to understand, easy to calculate. It can be found out from the graph. It is easy to calculate, easy to understand, and it can be found from the graph. Demerits. It is not rigidly defined. It is not based on all the observations. This is our central tendency and its merits and demerits. Now some theorems. At first, sum of deviation about mean is 0. Sum of deviation about mean is 0. Summation xi bar equal to 0, or summation fi xi minus x bar equal to 0. Sum of deviation about mean is 0. So let x1, x2, xn be an observation of the variable x with frequency x1, x2, xn, be the n observation of a variable x with frequency f1, f2 up to fn, where summation fi equal to n. So we know from group data mean x bar equal to summation fi xi by n. That is summation fi xi equal to n x bar. Now summation fi xi equal to, if we multiply by fi we get summation fi xi we find n x bar, summation to n x bar equal to 0. So summation fi xi minus x bar equal to 0 for group data proved. Next, sum of squares of deviation about mean is the least. Sum of squares of deviation about mean is the least. That is summation fi xi minus a whole square less summation fi xi minus a whole square, where x bar not equal to a. Our common dialog get x1, x2, xn be n observations from a set of values x with frequency x1, x2, xn, and a is any value, any constant. A is any constant where x bar not equal to a. So we can write summation fi xi minus x bar equal to 0. Now xi minus a whole square equal to xi minus x bar plus 1 minus a whole square, a plus b whole square, a square plus b square plus 2 a b. Xi minus a whole square equal to, if we multiply by summation fi If we put these values, we get summation fi equal to n summation fi x minus f equal to 0, so this term is 0. Since this is positive value, so we compare this and this term, we can write that is let's equal to summation xi minus a whole square, where x bar not equal to a, this is true. Next, arithmetic mean depends on origin and scale. Arithmetic mean depends on origin and scale. Arithmetic mean depends on origin and scale, that is x bar equal to a plus cd bar. Let x1 x2 xn be a set of n observations of a variable x whose mean is x bar, that is x bar equal to summation xi by n. Let di equal to xi minus a by c, where a is origin, c is scale. So from cross multiplication we can write cdi xi equal to a plus cdi, both sides by summation x, multiply both sides by summation xi and a plus c summation di. Dividing both sides by n, সুতরাং summation xi is assuming x bar a plus c d bar. So we can say that x bar depends on a and c, that is x bar depends on origin and scale. Combined mean. Combined mean for two sets. Combined mean for two sets. Let x1 has x11, x12, N1 observations and x2 has x21 to 2 x2 and 2, that is N2 observations. Then mean of x1 bar equal to x11 x12 x1 n1 divided by n1. That is x11 x12 n1 equal to n1 x1 bar. Similarly, x21 x22 x2 n2 equal to n2 x2 bar. Now the mean of the combined set. Now the mean of the combined set is x bar c means combine x11 12 x1 n1 plus x21 2 x2 n2, that is n1 plus n2. Now put these values n1 x1 bar n2 x2 bar divided by n1 plus. This is the combined mean of two series of data set. So viewers, no more today. See you again inshallah next another day. Allah Hafiz.